Hey guys, this is Mr. Grice for Algebra 1, section 11.1, Notes, Day 1. Today we're talking about simplifying, multiplying, and dividing radical roots. Our learning target today is to be able to simplify, multiply, and divide monomial radicals without rationalizing. Okay, now, key thing to know is the property that we're looking at first. Okay, and the property of radicals is saying that if you have a square root of a times b, you can break that up into a times b. Okay? Now, simplifying radicals. What we need to do is you need to find the biggest perfect square that divides the number evenly. Okay? So you're going to take a number and you're going to divide it evenly, and then you're going to split it into two roots. So it kind of looks like you start with AB and then you break it down. That's what we're going to be doing first. Okay? It's going to go into a perfect square and the remaining factor, and the last thing you need to do is to simplify. So the first thing that we need to know is, what are the perfect squares? Now, perfect squares would be like 1 squared. Well, 1 squared is 1. Well, what's 2 squared? 2 squared is 2 times 2. That is 4. 3 squared, 4 squared, and it just keeps on going. Okay, you guys should know all the way up to 12 by heart. When you get to geometry next year, they're going to ask you to memorize all the way up to 25 squared. Okay, so you guys got to get started. Help yourselves out by memorizing these. Okay, on every sheet, every quiz that we take, it would be beneficial for you guys to write these numbers down to help you out. Okay, so simplify the following radicals. What is the square root of 36? Well, the first thing you always want to do is see if this number is on this list. Okay, and it is. Okay, the square root of 36 is 6. So when you simplify this, you would just write 6. Now, if you were using your calculator, you would write the square root of 36, and then it's going to give you a number. And that's simplified. That's exactly what we want. Okay, but when you've got the square root of 363, we don't want that. We want a number. Okay, and so what we're going to do is you're going to write 363, and we're going to divide it by the closest perfect square. Okay, and that's 144. So 363 divided by 144. Does that come out evenly? No. So then we're going to try 121. Yay. Okay, that works. And that breaks it down to 121 and 3. So 121 times 3. Okay, and the square root of 121 is 11. And that other part stays 3. Okay, so we're breaking it down into a perfect square, and then it's going to have a remaining factor. Okay, so let's try again with 320. 320 is not on my list, so we're going to start with 320 divided by 144. No. So now 121. No. 100. No. 81. No. 64. Yay. So you do not have to write all of this stuff down right here. Okay. We want to know what it breaks down to. That's the important part. Okay. Because this breaks down into the square root of 64 and the square root of 5. And when you break that down, you get 6. I mean 6. The square root of 64 is 8 square root 5. Okay? So we got 108. The next closest is 100. Then you try 81. Then you try 64. Okay? None of those work. The one that works is 36, and it goes into 3 times. So you guys can go. If you just type this in your calculator, oh, doesn't work. Doesn't work. Doesn't work. I skipped 49. That doesn't work. There we go. Okay. So it breaks down into 36 times 3, which is 6 square root 3. Okay? Now, what happens when there's a number out front? So, we are still going to break down 216. Okay? So, 216. Now, don't just be like, oh, oh, that's not even a perfect square. But, let's see, does 9 go into it? Don't start at the bottom. You got to start all the way at the top. Okay? So you start at 144. No. Oh, not times. Divide. Divided by 100. No. 216 divided by 81. No. 64. 49. No. 36. Sweet. So it's 36, and the remainder was 6. So these are the two numbers that it breaks down to. Okay, that 5 still stays out there. Okay, but now what's the square root of 36? It's 6. So once you do that, you have to multiply those two numbers. Okay, once it goes outside, you multiply with the number that's out front. Okay, so then our final answer is 30 to the square root 6. Okay, so 125. What does 125 break down into? Okay, you should have broken that down into 25 and 5. Okay, the square root of 25 is 5, and you're left with the square root of 5. And then you multiply the coefficients, which is negative 15 times the square root of 5. Okay? Why don't you guys try number 7 and 8 on your own? Good luck. And pause the video. Okay, and there are answers. 8 breaks down into the square root of 4 times the square root of 2, because we're looking for which perfect square it goes into. Oops. Okay. Square root of 4 is 2, and then 4 times 2 gives you 8. 27 breaks down into 9 times 3. The square root of 9 is 3. And negative 2 times 3 gives you negative 6. All right, let's move on to the next property. It says property of radicals. You can go ahead and start writing that down. So the property of radicals means that when you have two different radicals, you can multiply them together and then to simplify. Okay, so but you would multiply the coefficients if you have them, and then multiply the insides or the roots together, and those stay in the roots. Okay, just a reminder, both of these right here those are your coefficients. Okay, the coefficients are the numbers that are outside. Anytime you hear radical, another way to say radical is the root. Okay, and simplify, that's the same thing as to reduce. Okay, so number 9. We're going to multiply the 2 times the 10, and that's going to give us 20. So we want to break that down. Okay, the perfect square that breaks it down is 4, so it breaks down to the square root of 4 times the square root of 5, and the square root of 4 is 2. Okay, so we would multiply the numbers inside. What's 8 times 8, guys? Well, 8 times 8 gives you 64, and the square root of 64, well, oh, that's one of the perfect squares. Okay, so let's notice something. When you had the square root of 8 times the square root of 8, our final answer was 8. What do you think that's going to be? Well, that's going to be 2. You have the square root of 3 times the square root of 3, that's going to give you 3. Okay, and the reason that is because 8 times 8, that's 64, and the square root of 64 is just 8. Okay, all right, let's look at number 11. Now, don't be fooled by negative 11 or number 11 because that negative sign's out there. They're just saying negative 1. There is a negative 1 on the outside, but that doesn't matter with the 45. Okay, so with the 45, the closest square root is 36. That doesn't go into it. What about 25? No. What about 16? No. Well, what about 9? Yes. Okay, so this breaks down to 9 and 5. The square root of 9 gives you 3, and so you're left with negative 3 to the square root of 5. Okay? Alright, let's look at 12. So, remember, outside with outside and inside with inside. We've only got inside right here, so these are the only things that you're multiplying. So, that changes to 4 square root of 80. And now when you start breaking 80 down, 64, no. Well, it might be, hey, Mr. Grice, 81's really close. Well, 81's over it, so it's not even going to work. Okay, so we tried 64, 49, 36, 25. Remember, you should always start at the highest and work your way down. Okay, and so we get 16 and 5. Okay, remember to keep those both inside the square root. Okay, square root of 16 is 4. And so you're left with 16 to the square root of 5. Because you multiply 4 times 4, and that gives you 16. Okay, number 13. Outside with outside, inside with inside. Okay, so we're going to get negative 6 times the square root of 9. Okay, well, you'd be like, whoa, Mr. Grice, I remember that right there. And I know the square root of 3 times the square root of 3 is going to give me 3, which is true, because the square root of 9 is 3. And then simplify, we get negative 18. All right, number 14, why don't you guys go and try it by yourself, pause the video, and see how you do. Okay, well, negative 4 times 5, it gives you negative 20. And then the square root 10 times root 10 gives you root of 100. But you can skip and go straight to here if you know that. Okay, but then negative 20 times 10 gives you negative 200. All right, I want you guys to pause the video and then write in the first 12 perfect squares. Okay, did you write them down? Look at the other side, guys, because we already wrote the answers. Okay, well, you guys should have gotten all of those right because they were on the other side. Okay, now we're talking about the property of radicals. Okay, and this one is when you have a radical, a nice big one, you can break it down into two parts like that. Okay, so one thing though, very important, is that your final answers may not have a radical in the denominator. Okay, there's actually two things about fractions that are illegal. Okay, you cannot have a 0 in the denominator or a square root. Okay, that's not good. You can go to math jail for that. Okay, so be careful. Now, dividing radicals means you need to simplify the numerator and the denominator separately and then reduce. Okay, so when you're looking at number 15, can you simplify the top? Are there any of those perfect squares that go in there? You're like, Mr. Grice, one does. Okay, well, technically you can write the square root of 1 times the square root of 3, but the square root of 1 is 1, and you're still pretty much left with the same thing. Okay, but now what about the bottom, the square root of 9? Well, the square root of 9 is 3, and so we just carry that over. Okay, the key thing here is you cannot cancel those two things because these are two totally different numbers. You can't just be like, well, they both got 3, so I'm going to reduce them. You can't do that. Okay, that's your final answer. Now, let's look at 16. What can you reduce that to? Well, the top's going to break down to the square root of 9 and times the square root of 2. And the square root of 2 just stays like that on the bottom. Okay? So the square root of 9 is 3. Now, can we reduce anything? Yeah, you can cancel those out because it's the same thing. And now you're just left with 3. Okay? Now, number 17. We've already broken down 216. It was on the other side. Okay, and that was 36 times 6, and now 24. Now remember, when you're breaking this down, you're going to start with the closest one, which is 16. Then you're going to go to 9. Doesn't work. Then you're going to go to 4. Okay, always work backwards. So it's a square root of 4 and the square root of 6. Excuse me, guys. I'm sorry. I hope that wasn't too loud. Okay. Now, your square roots of 6 cancel. And then you're left with 6 over 2, which reduces to 3. Okay? Always reduce. All right, now looking at 18. Now 18, they didn't break it up for you, but when it's like that, you can break it up yourself. Okay, the square root of 9 is 3, and the square root of 16 is 4. And you're done. You can't reduce that any further. All right? Same with 19. You break it down yourself. The square root of 36 is 6. The square root of 81 is 9. And now you need to ask yourself, can you reduce it? And yes, you can. That breaks down to 2/3. Okay? Now, let's look at number 20. All right? Breaking down 27, that's the square root of 9 times the square root of 3. all over 3. And you might be like, oh, look, I can cancel those. No, you can't, okay? That's just like problem 15, okay? The square root of 9 is 3, root 3, over 3. And oh, look at now you can cancel something. But don't forget what's left over, okay? Now, I want you guys to try 21 and try 23. You guys can work those out. We're going to go through 22 real quick, though. All right, so breaking down 12, it's the square root of 4 times square root of 3. And now the square root of 16 is 4. Okay? Now, let's break that down. Square root of 4 is 2. You're left over with 3, and then 2 times 4 is 8. Can you reduce that? Yes. 2 over 8 does reduce to 1/4. Okay? And make sure that you leave the fraction, the bigger number, on the bottom where it belongs. Okay? In the specific one, it stays on the bottom. So go ahead and pause, try 21 and 23, and then the answers will be up in just a second. Okay, and there's the rest of the answers. Now, if you have any questions on this or you need extra assistance, please come find Ms. Carranza or myself. Otherwise, that's it for Algebra 1, 11.1 notes, day 1. Thanks for watching.